So I guess 3 o'clock, almost on time. Hello and welcome for today's webinar. This is the second part of the GY LS300. And let me see, is there just the news? So, and this is the second part, as I mentioned, for the GY LS300, and it's a very special part today for talking about optics on the GY LS300, which is a very interesting part, especially for the variable scan mapping and what you can do with it and what lens recommendation we have. First of all, let me explain that normally I like to use practical work instead of a PowerPoint, but today is an issue I have also to use PowerPoint at more or less at the end, but still I want to keep the practical issues, and I like to talk a little bit basic things at first. I think that makes it easier later on to understand the other information which you get from my side. Anyhow, I like to explain the lenses in three categories for this camcorder. The category 1 are lenses which have normal electronic function as you use like from a video camcorder, so with electronic zoom or an iris or optical image stabilizer or autofocus system. That's our category 1 optics, but this is quite limited. There is basically 2 lenses which we can recommend for that one, but the list will be increased more and more and more and more. MFT lenses will come up with have these functions, and also we updated and tested these optics. The category 2 optics are photo optics, which you maybe have somewhere stored at your home or somewhere else, and you like to use, for example, EF mount lenses to the camcorder. That's another option which I call category 2 optics. Especially also there are existing optics and even new optics with electronic support, but there is a lot of limitations and you have to learn how you deal with these limitations. So don't expect that you have already a lens with lots of features like autofocus built in or whatever. You can use that on the camcorder. Maybe that will be not possible because of course these lenses are also made for a dedicated optical chassis or system which you have behind. So there are also some limitations. And the category 3 is basically what you see here on the image here on my side, this one here, which I called, let me use that name, Cine lenses, which is a fully manual operating lenses, which I prefer to use with that camcorder. If you, again, I told you yesterday, if you search a camcorder which you like to use mainly for regular video shooting, then I recommend to use a GY-HM200 or GY-HM600, 650, that kind of category of cameras instead of this one. This is what I mentioned yesterday for the creative people, and you do the experience, or it's a second camera for do the shooting. Well, let's have a look to my studio operation, and you can see I prepare a lot of things here on my desk, and this I like to talk with you. And yesterday I mentioned, let's have a quick look to the front area of the camcorder. Let me remove the dust cover here. So let's zoom it quickly up. So, and our main point for today is what you see here is our super 35mm sensor. You see also the electronic connection to MFT conformed lenses, and we have an MFT mount. And that is a lot of mismatch what you maybe think in your brain. First of all, it's very important that you understand that the question is not, when you like to use a lens, is not to say I need an MFT lens. Because when you say I want to have an MFT lens, then you mean that you have a lens which is designed for an MFT sensor, which is 30% smaller than a super 35mm. The real question or answer or information from the dealer to the customer, or from the customer to the dealer, is I want to have, for example, a full format lens with an MFT mount. Or I want to have a full format lens with a PL mount or with another mount. And this is an important point which you have to mention, especially for the optics, because the optic is designed, and the information on the optic, for a dedicated sensor material like film or an electronic sensor. Well, it's a little bit an issue. For example, we can use, instead of an MFT mount here, we can use a PL mount, but then we limit the whole camera chassis just to an PL lens ratios. So by using this MFT mount, we can increase the possibility to use different lenses on that camcorder. Even they're not made for super 35mm, thanks to the variable scan mapping. Well, we have to look a little bit about basics about it. And for the basic, I like to make a simple drawing. And let me move the camcorder here to that bottom. So I guess it's possible to see. I make some simple drawing. First of all, we have to understand what is our focal length, or focal lengths on an optics. Well, let's say make a simple drawing of an optic here, and I draw a simple lens eye here. Of course, a lens is much more complex. So when we have a dedicated lens design, our light maybe goes this way through the lens to an endpoint, and here is our sensor. When we're talking about the focal lengths, we're talking about the distance from here to here, and this is exactly our focal length way. So if the total design of the lens, and we're talking here about a full format optics, is made on a mechanical design for a PL mount, then we have this distance A. Let's call it A in this version. Now we make the same drawing below, and we have also full format optic, and okay, let's do this. And the lens is designed, let's say for MFT, let's say for a mount like MFT mount, then exactly we have a shorter distance here. So this is our original mount, but now our distance is shorter, and we have a different focal length. That's B. I'm make it that here in red. So that's our different issue. It will be very quickly clear when I show you in comparison. Say this is our PL mount here, and I guess you can see, let me open that up a little bit. So we have our PL mount here, and here we have an, instead of an MFT, let's say this is an EF, and this is the EF adapter, and it's very easy to see that there are mechanical difference, and this is our focal length. So, and you can easily understand, when I use an MFT, I have the shortest distance to the sensor, which allows me to use a simple mechanical adapter to use different kind of lenses. And that's the reason why we're not choosing a PL mount in generally. So we use an MFT mount, and within the MFT mount we can use MFT optics, which starts here at that point. We can use EF optics, which have a different focal length, but it's possible to use without any optics, and we can use PL mounts. So that increase a lots of this lens ratio. Another point is about question of grouping factor, which all of you have. What is the grouping factor of an optics? Yeah, first of all is that you calculate on a full format lens, which has a ratio of 36 millimeter by 24 millimeters. This is the window which you have. A super 35 millimeter sensor is a little bit smaller, and you will have a general group factor from round about 1.6. To calculate the group factor, you need to know the diagonal area of the sensor. And the most people who giving the group factor gives you this mechanical diagonal ratio. the mechanical point is not really correct. So better is to get the pixel by itself. So we have 5 microns here for each pixel, and then we have to calculate the pixels that we really use, and that gives you original 100% crop factor. But it's too complicated at the end of the day for daily work. So it's much easier to say, okay, it's a crop factor from around about 1.6. So that you know when you use the lens and you have the information which you get here in front of a lens, all these values here have to be grouped by 1.6. Anyhow, this is for the full format optic. In case you use an MFT optic, then we have the scan mapping, which exactly match the lens with the right values, and you don't have to calculate a crop factor, which is a benefit. And later on you will see that in physical when I show you that on the camcorder itself. Another point is when you're using the crop factor, and I make you a simple calculation. Let's say we have a crop factor from 2, and we have a 100mm lens. The most people say, oh, I have crop factor 2, my lens is now 200mm. And this is not correct. It makes your brain simple to think. That's of course okay, but we're not changing that 100mm. 100mm is a fixed value. It's a physical value. What we really change is the view angle, the field of view, and this is changing in the horizontal and on the vertical. So when we're talking about crop factor, you can talk also about the crop factor in case of vertical, horizontal, or diagonal. For the easy world, we're using the diagonal because this gives you the whole range, and don't take care if you're using 60:9 or 17:9 or any other aspect ratio. So we use for the crop factor the 60:9 value. So what does that really mean? Also look to the paper here. And I'm also like to do a simple drawing for better understanding this point. Let's use an object. I have a small camcorder here. Put that here on my table, and I do an optics here in the center. Let's make a little bit bigger optic like this, and let's use a sensor. Let's say this is our super 35mm sensor. So here, that's our sensor, and based on this optics we have created an image. Let's say that this is our light which goes through the optics, and this is our object which we have. You can simply see that. So when I have a 100mm optic which is designed for this particular sensor or a full format sensor, whatever here, then we get this kind of imaging. Now we use a different sensor. Let's say we use an MFT sensor here, which is about 30% smaller, and I make this with red, you can see this. We're not changing the lens. So 100mm is still 100mm, it's nothing to change. The only what we change, when we take our image scale, like here, and like here, on the same point. So then easily you can see when we use that area now, that's our new field of view. It's exactly this ratio here. So that means our new image is here. So as you can see, when we use a smaller sensor, and by keeping the lens itself, we get a different area of the picture here. It's the cropping which we do by the field of view. The lens is still the same, physical 100mm, but we change the field of view. Basically, it's also a kind of digital zoom, because with the original size you get the full area of the object. With the smaller one you get only the smaller area. Well, that this is a physical point, I can show you also with another experience. And I have two optics here, and let me move that a little bit up. So I have two optics. pull it up. So what I do is a kind of a small experience. One optic here and one optic here. And when you take your optic in your hand and look to the optic, so this is a 50mm optic, this one here. So there is a trick where you can see that you don't change any physics on that optics. I open the iris fully, infinity focus, and this optics which we have here is the 80mm, so 85mm. And the basic principle is, you remember as you was being a child, you take a light source, and I do that also on my training issues. So, and then we can use the measurement tool here. There is one mistake which is not 100% correct. I'll explain you after the experience. So I put that here on the optics, and what I do, I hope you can see that it's not so really visible for the focusing point. So when I now move that optics, I get the sharpest point around about here, and when we're looking then to the area which we measurement here, then it's almost quite similar to the focal length which is given here, 50mm, round about 5 centimeter here where our focusing point is here. We can do the same with the other one, which is 80mm. So we use the lens, have a light source between, and then we do the maximum focus which we can reach on the unit. As you can see, unsharp, the sharpest point, and we're looking here to the measurement is around about 8 centimeter which we have. Well, this example is good, for example, if you have an old lens somewhere and you don't know how many millimeter this is, please don't use a flashlight. This is the technical wise not correct, because there is also a focus issue when I move this light source. So it's important when you want to do this test, you must do it outside, because you need an infinity light source. For example, the sun. If you use the sun, you can, with the burning point, you can do the measurement, and then you almost know roughly, very close, how many millimeters this lens will be have. That works with fixed lenses fine to judge if you have such lens. So we don't change physical items here on the lens, we use only the field of view. Well, then we have an option to use different kind of adapters for the optics. First of all, it's important when you have the camcorder here. Let me move back to the camcorder itself. So you see the electrical items here. Whatever you use in adaptation to the camcorder, please note, switch it off, then mount the adapter if you use one, or you use the MFT lens, then switch it on. Otherwise, you're going to have data error. By the way, this is the same procedure which you normally should do on a DLSR, not simply change the optics. I mean, maybe some of you already do it, but it's not recommended. Switch down the hardware, put on the lens, and then switch on back the hardware. If you use an adapter which has also electronic support, mount the adapter, mount the lens, and then switch off the unit. Switch on the unit, sorry. And the same opposite. If you want to change the lens, still you have an adapter there, which is active adapter, then of course switch it off and switch it on back when you have changed the lens. And when we're talking about adapters, let's have a look to one of these adapters. First of all, a quick view to a PL mount adapter which I have here. So, and you can see that there's really no trick. What I mentioned before is an empty hole here. So there is no optics, and it's easily to mount this PL mount adapter here to the camcorder. There it is, and now you can mount an PL mount. Again, the benefit is we have a super 35mm here, and we have the MFT mount, which allows us to use different kind of mounting system without lenses inside. Well, sometimes you find adapters which already use a lens inside, or have a lens inside, and this is something, for example, for the EF mount adapter, which I have here. And before we do that, let's have a small information to that. No, it's the plastic. Okay, here we are. So both of these adapters, they have some support, and let me move that on here so you can see that. And I removed that already because these adapters, normally when you purchase here from Metabones, for example, they have some support holders, because you know you have a very heavy lens when you mounted it, and you have the heavy lens here in front, and that is a very stressful for the mounting system. But we have on the camcorder our filter, our ND filter, and maybe that comes in junction with the ND filter. So there are two screws which you have to remove, and you can remove the holder. The tools to remove this holder, which is here, it's coming with the box, with that unit. Anyhow, if you use a PL mount, it's much better to have an extension support by a rig, and you support the lens itself, not the adapter, except the lens itself, because the lens is heavy glass, it's heavy, and it's better to support that. It's seen, as you have seen here in my background of this side, background here, this large sensor, this set of support there. So then we have here the EF adapter. This is EF to MFT, and there are two versions, for example, for Metabones, and I mention Metabones here because at the moment that it's the only one which supports electronic information to other hardware. So this one has a lens. This is called the speed booster, but you get the same thing without lens. Well, if you want to use the speed booster or not, it's basically up to you. So what is actually the difference, and why it calls speed booster? In the photography, you say the camera is a speedy camera, means it's a light sensitivity camera, and it's called speed because speed is faster shuttering, so it gives you more light in a quicker time. That's why it's called speed. And what this speed booster does, it has an internal optics, and if you use a full format MEF lens here, it reduces the image to match to a MFT sensor, and that gives you one step more, one f-stop more. So you have the light gives more light because all the light is pick up down to match the MFT sensor. But of course, you have a super 35mm sensor. It's basically not needed to use that. You can use it and then reduce the sensor scanning to MFT, or you use super 35mm and take here just the regular adapter. It looks similar without the glass, and it takes the light one by one to the sensor. Anyhow, here is electronic, and there is the electronic connection. Again, switch the camera off, mounted it, put it on, put the lens on, and then switch it back. Important for this Metabones adapter is that it looks harmless, but it is electronic inside. That's a real microcomputer in. And also this needs a software update. So if you purchase this Metabones adapter, you can find the rubber here. Open that, and then you see a micro USB port. And with this micro USB port, you go to your PC and you get a firmware download from the Metabones website. And make sure, when you like to use this adapter with our GY LS300, please make sure that the firmware is higher than 1.5. So maybe 1.5A or 1.57. So that is, you can download from the Metabones website. To make this firmware update, you need a USB cable, the software tool, and no connection to an optic, not connected to the camcorder, simply like I have it in my hand, make the connection to the PC, and then you rewrite the microcomputer here inside this adapter. What is very important, that this takes only 2 minutes, but it's very important that you understand when you use EF lenses, there are limitations. Not all lenses support everything. For example, autofocus is generally not supported by this adapter, and there's no other adapter which can do that in the moment. We have a plan for another company which coming soon, maybe in the next 2 months, and our idea is also to support that, so that you can purchase this adapter from our side, not from the Metabones, is a different company. anyhow, but maybe it will take around about 2 months to get this adapter, which has a little bit more functions than this one. But so the general items like iris or like focus, that is mainly supported. But in general, at the end of the day, you have to check that with your lens. Again, the lenses are made for different chassis, so not everything can be work in that way maybe you think of. And also it's important to learn one difference is if you're coming from the video section, you have a standard video optics in the past, and you have a smooth iris operation. Again, you're using a photo optics here, and the photo optics same as you have here on the lens, and you move that's not always smooth like this one, like a mechanical one. There is also in the electronic one is a step, for example 1.5 to 2, 2.5 or to 4, it's steps. So maybe the iris will be not working smoothly as you know it from a normal video, but this is depending on the lens. So if you find out this and you take the iris control on the camcorder and you see the image, the brightness jumps up, that is with the regardless to the optics which you use in front. But there's no worries, you can change your shutter, you can use your exposure on the camcorder itself, so I think you can handle this. So that's for the adapters here. Well, there is another option which is a little bit tricky. If you want to do an experience, maybe you have at home you have old C-mount optics. This is a simple mechanical adapter you see with C-mount. Well, there are still old lenses, and but maybe the lens is sometimes very useful, like for research, for a microscope, or even if you want to have dedicated shooting, like to an optical scope to search our space. However, if you use that, there are also some items which is very important to look for. First of all, if I take a lens here, it's a small tiny lens, you can see that. If I mount that, screw that in, and there is one important point. So the lens is now in, and you can see the lens comes out of this adapter. Here, this is the lens part. This is not working. The maximum what you have is really the end of this adapter. So the lens is too long. If you do that, and we're looking here to the camcorder, and that you maybe damage this surface. So be carefully what you're doing with that one. If that lens, you can use only a C-mount lens when you have the option that the lens is not going further than now. You can see, now it's plain. But then you need a lens which has a focal length adjustment, otherwise the lens will be unsharp. Another issue is if you use an older C-mount like this one here, you can screw that on. So you can see I have it on. The lens is not coming out, but here we have another problem, and I zoom that up that maybe it's visible. So I guess here we can see it quite clear. So you can see that this adapter here blocks the screw in. You see here this mounting, so that's too close. And maybe also here you see there are two rounds missing, so normally we need to come a little bit more that the lens will be matched and also the focal length will be work. So that's a try and error and a principle. If that is an experience, if you want to use with C-mount, even that it's theoretical possible to use, but this is depending which lens you have and maybe which adapter you have. There are in the market also other C-mount MFT adapters, but keep in mind the depth of this adapter should take any damages here to the surface. Anyway, this lens is a good example how our scan mapping works in the camcorder. So even the picture will be not 100% sharp at that moment, but this is a good example to explain optics. So, and there is a point which I like to show you here on the screen, on the paper. First, here we are. Our understanding for imaging is exactly that what you see here on that small screen. This is our daily view. We see a rectangle image. And what we have to understand when we get an image from an optic is not this form. The image from an optic is always an image circle, so it's round. And again, I can use my flashlight here to show you simply what I mean with that. When we get the light in, and simply you can see that here. When the light comes in and the picture information is there, it's always a round circle. And it's easily to understand when we have this circle that our image sensor, that's when I do the projection here, so our image circle must be matched in. So when I put a sensor in, and let me use the red one to make it better visible. So this is our sensor, and then our lens must be exactly, the circle must be matched into that area like this. If the light is too small, then we get shadows on the screen, so here, and then basically the optics will not work with the camcorder. But in our case, we're happy we use the GY LS300, and with the GY LS300 we really can solve this problem in a certain ratio. Okay, here we are. So, and I mounted here the C-mount just to have a better demonstration of the function. And let me move the optics in. So here we have our camcorder, and I show you what's coming out now. Switch on the camera, and I show you what will come out of this optics. So we need a one second to get an image. Here we are. So let me switch to the source. Here we are, and this is our image. What we get looks like an endoscope, actually, like an endoscope image. Again, the optics goes not too deep into that, but for the demonstration it's good enough to show it. So another one, let me switch off all the information what we see here on the screen, so we can see, you can see the poorly naked image. So if you have a camera, another Super 35 camera, and you put any other optics which not match to the Super 35mm lens, you get an equal image what you see here. We have a clear image in the center, but on the outer side we have a clear vignition or karare, so said in Japanese. So that is basically you cannot use the optics. But in the case of the GY LS300, it's easy to handle this, because you can go into the menu option, go to your system record, the record set, and go to the variable scan mode. And we make a very graphical interface. You can see this is now the full sensor, and when I change that, you have a variable scan mapping, and you can follow that easily on the screen. For example, when we go 30% less or 20% less, sorry, to an MFT optic, so that is now fully matched when you use an MFT optic. But here we're using even smaller lens. We can go down. So this is the example for a Super 60, and we can see we are very close here that the optics basically works like a Super 16, but still there are some unsharp area. So it's up to me. I can use that all lens and set it to HD. I confirm these pictures, and now you can see my camera scan this area and have a look. You can use the lens as regular as you want it. Well, this is the most useful function, so to adapt the lens. So if you get an MFT lens which is made for MFT sensor, don't worry, it will work by simply using that virtual scan mode. Again, show it. Go to the scan mode area, go up, for example here, and go up to MFT. You can see my screen is still not perfect, but if it won't be an MFT lens, then it will be matched perfectly. Let's go back to the full screen. Record set, VSM mode, and then we go to the full screen format back. Full format super. Sorry. You have to confirm that when you change it. Super 35. Okay, Super 35, and we are back here. So okay, let me remove that optics, and I can do that when the unit is running, because what I use here is no electronic support, just simply mechanical. Let's use a standard lens so that we get an image. Here we are. So now we have a regular image, and the interesting feature which I explained yesterday is the typical bokeh effect which you get with the lens. You know, I have here limitations for the presentation, so let me allow to use the keyboard which you see here in front, so you can see what when I change here the focus. So now my front part is in focus, and it's easy to do these typical shots where my front part is unfocused and my background is focused. You can do that with a smaller sensor camera, but then with a zoom optic, but then you have to use a far distance. But I do that here just right in front. When you're looking here, I'm just here in front of the keyboard. So with a small size sensor, you cannot do this. This is the benefit on the large sensor format. So you can work really more in a case of experience or cinema like. But with the scan mode, and I want to do another experience with you. Let me put here that small optics as a reference part. Let's do that like this. Okay, we're on focus here, so that's fantastic. So, well, maybe you are a photographer in the nature area, you do documentation, like you do animals or birds somewhere, and you like to really use a super large optics. Well, you can make a selection. I want to work in 4K, which a camera can do. Or if you open with your mind and you say, okay, I do it in HD, but then you have a good opportunity to extend your lens. For example, let's take a super large lens like 1000 millimeter, then we can mount an extender in front. Here we can do an extender here right in front, and then use the super large optics. But then you see, okay, I need something more, and it's basically easy to double or triple that figure by what you learn is the viewing angle. If it can do a smaller viewing angle, we get only a part of the image. And this is a tricky thing with this feature. You can use that simply to have a digital zoom advantage with it. So for example, I use the full frame, but if I don't mind with the resolution, because that works better than later on when you do that by software. So we go here, and then we reduce the field of view, which we do by reducing the scan area of the sensor. Let's make it small as possible, and then I say OK, and you can see now you have a digital zoom up. So this is an additional tricky thing where you have that tool. And especially if you like to use long shots and have additional zoom when the normal zoom doesn't work or the lens doesn't work. This is an emergency case, or not only emergency case, is a case which you like to use maybe to bring your lens up. I did this, for example, we have the when you shot the moon. Last time I shot the moon with it. So take a large optics which I have at home and put an extender between a double extender, and I use that, and you have easily a full frame moon on your screen. This is a simple example where you can use also the scan mapping, not only to match lenses, it's also kind of good tricky thing to have some add-on value originally is not designed for that, but is a good item to use. Well, this is for the tricks and pieces, and we have also some other issues when we go. That is the information here on the screen, and let me switch back this information. And yesterday I already mentioned here that we have, and let me do this, and we have here, I must think opposite way. So we have our exposure time here in seconds, or the gain in dBs, and that is what I yesterday mentioned. It's easily to change. I want to repeat that for today. So you're going into the menu structure here, go to your LCD view area, go to the display settings, and then scroll down. So, and then you can see we have the gain, and also the adjustment which we have here is second. I cannot change this second to degrees. This is for the people coming from the film area. They normally like to use degrees. That's why it works only in 24p mode. And for the people who comes also from the photograph area, which maybe have problems to understand the dB section, you can change that to ISO here, and then you go out, and then you got your ISO identification. For example, I changed that to low lux now, and you can see your ISO goes up to 12,800, and it goes even higher when it goes to 36 dB. So that's an easy identification which ISO you use and which gain you use. For example, if I move that up here or move it down, so that's the easy indication when coming from the photograph area. Well, so that's for the theoretical term, and now let's have look some practical items to that. One thing I forgot, I put it yesterday on the table, but let me do that quickly again. Yesterday I spoke about this level, this rocker level, this zoom level here, and just want to repeat. There are a lot of electronic lenses, MFT lenses, with fixed lenses, but have electronic focus and iris, of course. This one comes in useless because these lenses are fixed lenses, no zoom motor, but you can change that to control the iris, which is basically simple in the menu setup. Going to the camera function, scroll down, and here you have the grip zoom, which you can change to the focus mode. So also this is a benefit to use that tool in case you have a fixed optic with electronic zoom. Well, I'd like to come to the PC area. So now we're coming from the practical point to a more theoretical point on the screen, and allowed me to do that quickly with you. And sorry that I'm not looking to your screen, because I have to look also to that screen. So what you see here this is the two recommendation optics. One, this is a zoom optics here, 42 millimeters, which is tested from our factory, and this is the Olympus one. Frankly speaking, this is my favorite one, which you have here. This is just a distance, that's not a power zoom. But this one here is the one which I recommend, the Olympus one. There are also fixed optics which recommendation, and just 2 minutes ago I get a new list which will be updated, and we will distribute that on a special information sheet on the website, which kind of lens, electronic lens, we supported. But keep in mind, this is only for the electronic lenses. Still, my recommendation is use lenses which is also the option to do fully manual operation. I think that is anyway one of the best way to work with that camcorder. So, and let's have a look, just a quick overview, which I talked just in a minute before about the sensors itself. So that maybe makes it a little bit different, better understanding now. You can see this is our normal photo area with a photo frame with 36 36 by 24 millimeter in this area here. You can see that. And this is our super 35 millimeter film format, 24.9 by 40 millimeter. In the case we're using 60 by 9 format. Well, when we look into the film area, then of course the most of you knows the CinemaScope format 235:1. That's the most DVDs you get at home. This is a typical CinemaScope format. Then there is widescreen 1.85. It's more the anamorphic area, and the Technicscope with super widescreen. And the new film format is super 35 millimeter. It's getting more picture information here because the audio track is eliminated, and increase the size to 24.89. You can see it's almost similar value, and the height depends on the aspect ratio. In case of 16 by 9 is 14 millimeter. That's our typical film format, and that's why our sensor will be matched. Again, this is the demonstration here about the image circle. You have seen that with my demonstration, practical demonstration. So the lens makes that kind of image, and you can see photography area is that we say 35 millimeter full format, 36 by 24 millimeters. You have APC format in the photograph area, digital, which is a typical size of 22.3 by 14.9 millimeters. And then we go to the film area, super 35 millimeter film, 20.9 by 40 millimeters, and there are also some other digital variants of that one, a little bit smaller, a little bit higher. But you can see when we compare that to film, it's exactly what we have with the super 35 millimeter sensor. And this is roughly a crop factor 1.5. And keep in mind, I say before 1.6 because I'm using the physical pixel area and not the mechanical area. Again, here's the example when the lens makes the projection. It's round, and the sensor have to match. Here is the example of a lens. We have 150 millimeter, and this is 50 millimeters, and it changed our field of view on that lens. So if we change the size of the lens here, then of course the viewing angle will be changed. And that's the focal length of the 50 millimeters here, and this is the focal length here on a 150 millimeter lens. So this is important, which I mentioned you before, with the adaptation. And as small as we can go to the sensor, as easier it is the adaptation to another lens. What is important by using different lenses, and what makes the camera so interesting, is to use different optics, the same as you use in a photograph. And if you work with that, you can reach different image views. This is all made same shooting, but we're using the different lens, different focal lengths on the optics, and you can see without changing any other parameter what influence the lens have of the image which you're going to shoot. And this is important, for example, if you do a shooting on a catwalk or a personal shoot. So then you make the decision which lens in which position, in which distance you use, which image effect you get as a result. And here is the example to mention the image field of view. For example, if we have a super 35 millimeter, we have this area. If we take a super 35 millimeter, which is close to the super 35 millimeter, it's almost similar, slightly cut off. And this is a micro four thirds dot mount sensor. So that's by using the same optic, this is your image view on this. And if you use a half-inch sensor video camcorder with the same optics, then this will be your picture in the same distance. So it's easily understand what is the meaning. The lens is still, for example, here the 50 millimeter lens, it's still physical 50 millimeters, but it's just the image field of view what we're changing to pick up the information. Well, the photographer's area looks exactly to that field of view, and he has to know which sensor he's using, and he makes the decision which lens I use for the shot. And keep in mind we have the super 35 millimeter and the MFT lens here. And here is another example. This is our image screen. When we use the sensor, it must be matched into that screen, and our picture result will be this. If the lens is a different lens for a different sensor, like here, and we use a smaller it's made for a smaller lens, like here, like an MFT sensor, and we using the Super 36, we get this black area, which is called vignetting or Carrare effect. And don't mind, we have the scan mapping, and with the scan mapping, like here, we can easily adjust that optics. Here's one important information in case of what you're going to shooting. If you shoot in 4K, the variable scan mapping works from Super 35 to minimum MFT size, because MFT size and any other resolution which go higher, it's the resolution it's coming from the lens. If it gets less than that, you have to switch the camcorder to HD, and then you can have the full range from full format up to HD. For example, a Super 16 lens has basically a resolution a little bit over HD, so and it makes no sense to use a Super 16 and shot in 4K. So you then easily you can switch to HD, and you can use the Super 16 lens. Even for your editing is no problem. If you downscale or upscale, that makes really no sense on an NLE system. So if you put that and you say, okay, the next shot I use a Super 16 lens, you have to switch to HD, use the Super 16 lens there. This is an interesting part also for film schools. So film schools basically have, okay, Super 16 is an old lens, but there's still a portfolio on Super 60 lenses in the market or in the portfolio, especially maybe on the film schools, and you can use all that lenses, and also you can train the people how you can use the lens and what effect the lens will have for your shooting or for the camcorder you like to use. So it's very flexible with the GY LS300. There is a bunch of optics in the market, MFT lenses, which you can use, and in with electronic support. The only remark again is you have to look, if you have that in your portfolio, which electronic support is given or not. You cannot expect that any MFT lens works with all these functions. Keep in mind they're made for dedicated chassis. So the general features like iris or like focus control, that mainly will work. But if you have additional option like OIS, an optical image stabilizer, or autofocus, that maybe you have to check, maybe is not working. PL mount adapters. PL mount adapters are fully mechanical. There is no electronic support. That means you have to make sure when you use a PL mount optic that is full manual operation. Or it has an external control. Of course, then you can use also an electronic lens. But in case of PL mount, normally make sure that you can handle that fully manual operation. And in case of EF lenses, it's not only Canon EF, there are also other manual lenses which using an EF mount. You can adapt this. You have passive adapters in the market. Then we have the same situation like on the PL mount. That means you have a full manual control of the lens. And if you use the metabones today, keep in mind there are limitations. For example, autofocus is definitely not supported. You can read that on the Metabones website. And maybe some other functions like OIS also will be not supported. So that is also let's say a try and error issue. We cannot make all the lists. We will upgrade it and test it permanently and upgrade the list, but there are tons of lists into that market. It's also possible to use other lenses. You get a bunch of mechanical adapters into the market, E-mount to MFT, etc. Nikon A, Nikon F, or whatever adapters is already in the market. You go to, for example, to Amazon. You can see there is a lot of adapter support, but they are all passive. So that means the lens which you're going to lose needs to be a manual operation. So you see, it is just a simple overview here. Like for example, MFT mount. A lot of companies, only a few, Zeiss, Raycon, Tamron, Samyang, Boya, etc. All these lenses you can use. Here is a bunch of optics, for example. And what is important next is that you think of, if depending on the lens construction, on the weight on the lens, you need some support tools like here, which your dealer can support, or the you as a dealer can support to the end user, is, and this is typical also meanwhile on the DSLR, the lens gets bigger, take a long lens, you have some support areas here for the zoom, for the focus, and hold the weight. Adapters I already mentioned. Here is another point for holding the lens. Yeah, and basically the last point which I have to talk here is about the ISO and the shutter. I already showed you the gain combination. It's easily to switch into the camcorder from gain to ISO indication, and in case of 24p and 24p you can switch to degrees, and here is an indication on that list. So if you're not familiar with the degrees, for example 180 degrees is around a 148 seconds combination or comparison when you switch to seconds, or 100 seconds here is 86.4 degrees. So this is for the people who already work with degrees. Frankly speaking, that's not so my part. I'm coming from the video section, so I like to know to use the seconds, but we give the support inside the camcorder that you can switch from seconds to degrees. That's so far it's all. Thank you for listening, and God bless you. Next time I'm the next 5 minutes here online, so if you want to do a call here on the line, which you see no, this way, there below, okay, you go away so that you can see the line if you want to talk, or you can use the chat box on your screen, and for the next 5 minutes I'm still here, and see you next time.